All right, today in quads, we are solving quadratic equations using square roots. So for some quadratic equations, you can take the square root of both sides to find its solution using the square root property. So just like we can use multiplying or dividing, addition or subtraction as opposites to undo equations, we use the square root property to undo squares. All right, so square roots and squaring something are opposites, like multiplying and dividing. So what our square root property is saying is that if x squared equals a, where a is a positive number, then the values of x are either the positive or negative value of that square root of a. So an example is if I have x squared equals 25, and I want to get x by itself, so I need to get rid of that square, that's where I take the square root of both sides. So the square root and the square cancel, so I'm left with x equals the square root of 25. Now what times itself equals 25? Because that's what the definition of square root is. It's something times itself to equal that value. So 5 times 5 gives us a positive 25. But remember, negative 5 times negative 5 also gives us positive 25. So our answers, we would say x equals plus or minus 5. And what that's really saying is x equals 5 and x equals negative 5. It's giving us two different solutions, but we're only writing it as one. That's what the plus minus is for. So another example, x squared equals 9. X could equal 3 or negative 3, because you could square both of them and end up positive. So you'd write that as, we would say x equals plus or minus 3. So there are really two answers there. All right. So a couple worked out ones here. This first one, x squared equals 16. So we take the square root of both sides. The square root of 16 equals 4 or negative 4. All right, next example in the middle, x squared equals negative 4. This isn't possible, all right, because we can't have a number times itself equaling a negative. A positive times a positive is positive, and a negative times a negative is also positive. And if we take a positive times a negative, well, then we don't have the same number times itself. All right, and the last one on the right is starting with an equation. They want to get the x by itself, and then if you have a square root on top and a square root on bottom, you can combine it as one big square root or take the square root of the individual parts. So you'll see some examples of that. All right, so let's start with some examples. All right, so first we have x plus 2 quantity squared equals 9. So in this one, everything, this entire x plus 2, it's all in parentheses. That means all of that is being squared. So since everything on the left side is being squared, I can take the square root right away to get rid of it. Oops. So the square root of the left side and the square root of the right side, they cancel, leaving us just x plus 2 equals, and the square root of 9 could be positive or negative 3. So if you're wondering, well, when do you need the positive and the negative? Well, anytime you are the one that put the square root symbol in, that's when you need to add the plus or minus. So here, I'm going to set up two separate equations. All right, so I'm going to branch off. I could have x plus 2 equal positive 3, or I could have x plus 2 equal negative 3. So now I just want to solve for x on both of these equations. So if I subtract 2 from both sides, I get x equals 1. Subtract 2 from both sides on the other one, I get x equals negative 5. So both of these are my answers. And we can plug them back in to double check. All right, the next one, I have 100x squared minus 49 equals 0. All right, now not everything is being squared. Only the x is being squared. There's no parentheses. All right, so only the x is being squared, not even the 100. So what I want to do first is isolate that x. So I want to get rid of this minus 49. So I'm going to go ahead and add 49. And if I do it to the left side of the equal sign, I need to balance it and do it to the right side of the equal sign. So I get 100 x squared equals 49. Now the x squared still not by itself. I need to get rid of that 100. And since those are multiplying, the opposite would be to divide. All right, so those cancel on the left side. And I'm actually going to leave this as 49 over 100. All right, the reason I'm doing that is because I recognize that 49 and 100 are both perfect squares. So the next step to get x by itself would be to get rid of that would be to get rid of that square. And the opposite of squaring something is to take the square root. So I'm taking the square root of the entire left side and the entire right side. All right, so since I put the square root symbol in, I need plus or minus. All right, and now the square root of 49 is 7, and the square root of 100 is 10. Whoops. So my answer is x equals positive or negative 7 out of 10. All right, and this one, I didn't need to set up two separate equations because I only had the x term by itself when I took the square root. There's nothing else on that left side besides x. All right, this third one, x minus 5 quantity squared equals 25. So since the entire left side, that entire x minus 5 is all being squared, I can go ahead and get rid of that square right away. So I'm going to take the square root. Square root cancels the square. So on the left side, I get x minus 5. On the right side, since I put the square root symbol in, I get plus or minus. And the square root of 25 is 5. All right, so now I have two separate equations because I have x minus 5 equals positive or negative, and that can change. So x minus 5 could equal 5. X minus 5 could equal negative 5. If I add 5 to everything, I get x values of 10 and 0. And there are my two answers. All right, I'm going to do the bottom left and then the one after that. The other four, I would like you to practice. So I'd like you to pause the video, try them on your own, follow the examples that we've done together, and then resume the video and double check to make sure you did them correctly. All right, so bottom left. 2x plus 1 all squared equals 64. So everything is being squared on the left side, so I can go ahead and take the square root. Square root cancels the square, and I get 2x plus 1 equals, since I put the square root symbol in, positive or negative 8. All right, so I could have 2x plus 1 equals 8, or 2x plus 1 equals negative 8. So if I want to solve this, I need to get that x term by itself. So I need to get rid of that positive 1 first. So I'm going to subtract 1. And I get 2x equals 7, and 2x equals negative 9. Now x is being multiplied by 2, so the opposite would be to divide. And I get x equals 7 halves and negative 9 halves. And those fractions cannot be reduced, so I'll leave them as is. All right, last one. 2 times x minus 3 quantity squared equals 200. So this one's a tough one because the only thing being squared is the x minus 3. All right, the 2 is not being squared. So I need to find a way to get rid of that first. Now, some of you might say distribute. All right, so if we distribute, everything is being multiplied by 2. So if everything is being multiplied by 2, I could just divide by 2 right away. All right, so instead of multiplying everything by 2 and then dividing later on, I can divide by 2 right now instead of distributing. So if I divide the left side by 200, I divide the right side by 200, I get x minus 3 all squared equals 100. And now I notice everything on the left side is being squared, so I can take the square root to cancel that off. And I get x minus 3 equals plus or minus, because I put the square root symbol in, and square root of 100 is 10. So break it apart into my 2 separate equations now. X minus 3 could equal positive 10. X minus 3 could equal negative 10. So if I add 3, I get x equals 13 and x equals negative 7. There are my 2 answers. All right, so now please pause the video, try the remaining 4 on your own, and resume the video to come check in. All right, so check your answers. This should match up to what I got. To do, let's get started on the practice and the LT check.